You may have already seen some of the amazing videos that showcase what artists are doing to push the boundaries of digital fabrication at Pier 9, or seen Pier 9 as a facility where Autodesk employees can come and fundamentally understand what happens after designs leave the computer screen. But today we walk down to Pier 9 for our product development update video, where we're going to highlight the differences between traditional roughing and our high efficiency roughing adaptive clearing. We're going to run our tests in 1018 steel with solid carbides from SwiftCarb so we can cut dry and really get in there with the high-speed cameras and see the chip formation taking place without the coolant in the way. We have our spike sensory tool holder so we can stream live data of the cutting action taking place, both loads and temperature. By the end of the video, I trust you'll have the confidence to start using adaptive clearing in your shop, which is free, by the way, with our Express products, to really start to reduce your cycle times and improve cutter life. So with that said, let's fire up this VF2 and jump into it. Traditional roughing passes are built off of a series of offset passes coming out from the geometry. Regardless of what the offset distance is, the tool will still see an increased engagement going into internal corners and driving into slots. These internal corners is where the tool is most prone to breakage. As we listen to the cut, we can hear that change in load coming into the corners and driving into slots. And monitoring the data coming in from our sensory tool holder, we see the spikes in load. So to maintain high feed rates, traditional programmers would take a light depth of cut. Unfortunately, this technique overuses the bottom of the cutter. In contrast, adaptive clearing maintains a constant radial load on the cutter throughout the entire cut. And we don't see those drastic spikes in load. Instead, we see a nice constant load. As a result, we can take a deep cut that uses the full flute of our cutter with a light step over. This actually extends cutter life while reducing runtime. As machinists, when we listen, we can hear the constant sound of a good cut. So let's change gears for a minute and talk a little bit about how we calculate our speeds and feeds. This becomes very simple with the basic understanding that there's always going to be a constant load on the cutter. If there's no high efficiency milling parameters for the cutter, we can simply start with the side milling parameters and allow the cutter to make a complete pass around the part and then begin to slowly increase our feed, because we know we're not going to run into a point where there's a spike in load. Now, I mentioned my little trick about making a full pass around the part. I say that because your first pass may be a little lighter or a little heavier based on the size of stock you've loaded in the machine. As a quick trick, it's always a good idea in CAM to define the stock a little large so that first pass errs on the side of being light, if anything. When using adaptive clearing in your shop, you may have noticed what seems to be a large number of retracts. While this is generally the faster way of machining, it's often more appealing to keep the tool down. In your adaptive operation, simply browse to the linking tab where you can adjust the maximum distance a tool can stay down for, change the stay down percentage, and apply a micro lift to lift the tool slightly off the machine surface when repositioning. By increasing the stay down percentage, we're now forcing the tool to stay down even in scenarios when it's shorter and would have taken less time to retract and rapid reposition. Now, because adaptive clearing is capable of taking such deep cuts, when we start programming 3D parts, we use a step-up pass to ensure the roughing operation leaves a constant amount of stock on our model. You may even notice that our stay-down linking feature can find a safe 3D path through the part when repositioning. Well, I hope you now have a better understanding of adaptive clearing and you enjoyed a behind-the-scenes look at what goes on here at Pier 9.